All right, for this example, we're going to find a point on this line so that the distance between the point on this line and that is minimized. So what are we trying to minimize? Okay, read the question one more time. What are we trying to minimize? Distance, right? Does anyone know a formula for distance? Huh? Maybe the distance formula?
Sounds about right.
Okay. If you don't remember it, it's just a fancy Pythagorean theorem.
Let me see how fancy it is. Oh, that's high class right there.
Yeah. This is Pythagorean theorem that went to college, basically. It's very fancy. So,
What college though?
Yale. So this is the difference in x's, right? So that would be your a squared. This is the difference in y's. So that would be your b squared. Okay. And then they just took the square root, so there's no c squared. All right, now the cool thing about having a point here is this one can't change, okay? So I can change this point, but I'm just gonna leave this point, okay? It's probably gonna be somewhere right here. So it'll be whatever my x value is, minus 1, right? And my y value, minus 2. So I just got that from here, 1, 2. 1, 2.
1, 2.
But, like I said, we don't like to have x's and y's. So any idea how I can write y in terms of x?
2x plus 3.
2x plus 3. Yep. So x minus 1 squared plus 2x plus 1 squared. Now, some people get super excited here. They're like, Miss Ampson, this cancels. And I'm like, no, that kills a puppy, okay? So don't just cancel the square root and the square just because they're both there.
What?
Oh yeah, that kills a puppy. Every time you do that, the math gods kill a puppy.
Who are the math gods?
You guys don't know that?
One of them is Ghost, huh?
So x squared minus 2x plus 1 plus 4x squared plus 4x plus 1. I just foiled while you guys were getting your life together.
You know, if the three are together, then like the world ends.
I'm not a math god.
That does that. And he records.
Who else?
He records it.
All right. Anyways, since we're recording this lesson.
Why don't you put ads?
Why are you
in
looking at us
this
like that,
Are
Miss Simpson?
you guys cool with that?
Yeah.
So I just combine like terms. I put it to the 1/2. What kind of problem is this derivative going to be? We got a chain rule happening. Good job. So d prime is going to be derivative of the inside, so 10x plus 2 times, and then derivative of the outside with the inside left alone. So 1/2. Leave everything alone to the negative 1/2. Oop. So that's 10x plus 2 over 2 root this business. That could be reduced. the cool thing about this is that I don't care where this is undefined.
Yeah.
Okay. I only care where the derivative is equal to 0. So what are my values going to be?
1 over 5.
Close.
5 over 1.
Negative 1 over 5, right?
Oh, yeah.
Subtract the 1, divide by 5. Now what? Sign chart. Something less than negative a fifth. How about negative 1?
Not the same.
Alright. So this it doesn't really concern me. Right? Because it's going to be a square root. So it's fine. What about here? Negative value. What about here? What would you plug in? 0, and it's going to be positive. So we found a min. Right? Negative to positive. And that's what we wanted. We wanted to minimize the distance. So the point is going to be negative 1/5, comma, what? How do I figure out that value? Plug into the original, which is way over here. Okay. So that's negative 2/5 plus 3. So that's 15 minus 2/5, 13/5. Okay. So that point's right here. Negative 1/5, like here-ish. That minimizes the distance. 13/5. And that does it for today. We'll do this one on block.